Hello Year 11. Thank you for your prompt completion of this work that I'm about to go through. I can honestly say you're the only class that I teach or am responsible for that I haven't had to chase to get work in from someone. So thank you for that, and long may it continue. I thought it'd be really beneficial for us to go through the answers to these 10-minute tests just to make sure that you're all in exactly the same position and that we fix any misconceptions that seem to have arisen. So we start with test 42. And question 1, when a person jumps onto a trampoline, energy is transferred from the gravitational potential energy store of the person to the trampoline's elastic potential energy store, and it asks how this happens, whether it happens electrically, mechanically, or by heating. The only one here that makes any sense is mechanically, because it's by motion. Second, true or false, after a substance is condensed, it can be sublimated to recover its original properties. If a substance has been condensed, then it has moved from being a gas to a liquid. Sublimation is moving from a solid to a gas, and so that is not the converse process. If I go from a gas to a liquid, I can't sublimate that because it's not a solid, so it must be false. Third, true or false, a live wire can still be dangerous even when a switch in the main circuit is open. That's true because my live wire is connected to the main supply, so it always has a potential difference of 230 volts. So if I touch that wire, I can connect to the ground, and therefore a current can pass through me due to that potential difference, 230 volts at the live wire, 0 volts at the floor, and therefore is still dangerous. Question 4 is just an equation you need to know, relating power, resistance, and current. That's P equals I squared R. B. 5, you also need to know the radius of the atom. It's approximately 1 times 10 to the minus 10 metres, or 10 nanometres across. You also need to know, incidentally, the radius of a nucleus, which is 1/10,000th of that, 1 times 10 to the minus 15 metres. 6, true or false, some energy is always wasted when an electrical device is used. The question here really is, can we have a 100% efficient process? To which the answer is no, and therefore this statement is true. Some energy is always wasted. Question 7, which of these is an environmental problem caused by generating electricity using hydroelectric power? The waste produced is dangerous and difficult to get rid of. No, that's nuclear fission reactors. It results in the release of sulfur dioxide, which causes acid rain. No, that's fossil fuels. It could result in a loss of habitat for some species. Yes, we need to flood a significant region of land. So C. And then question 8, electricity is transferred across step-up transformers. Step-up transformers increase the voltage. So it can be either A or B. And we increase the voltage when we transmit it long distances to reduce energy losses via ohmic heating. Then we step it back down, decreasing the voltage for safety for domestic use. So it must be A. Step-up transformers increase the potential difference in order to transmit that energy, that electricity, from power stations. Next we have some longer answer questions. A student has a source of radiation that emits one of 3 types of ionising nuclear radiation. She places the source opposite a Geiger-Müller tube and detector and records the count rate. She then places a sheet of paper between the source and the detector and records the count rate, and then repeats this with a sheet of aluminium instead of paper. Describe how her results will allow her to work out which type of radiation. The only issue here really was a lack of specificity and completeness in your answers. So if blocked by the paper, or at least a majority blocked by the paper, then your radiation is alpha. If blocked by your aluminium, but not paper, then beta. And if not blocked, then you have gamma. And you would have to have all 3 of those statements to get full marks on that question. Next, ethanol has a specific latent heat of vaporization. Of that, calculate the energy required to boil 0.6 kilograms of ethanol, and you're given your formula. So it's just mass 0.6 times 846,000. I take out my calculator. I have 0.6 times 846,000, which is 507600. Or you could give that to 3SF, because you note that they've given you a specific latent heat to 3SF. Then 11, you have an IV graph for a circuit component shown on the right. Which component and give a reason. You note that current can only flow in one direction, so that must be a diode, and your reason can be current only flows in one direction, or you could say that there is a very high resistance in the opposite direction, and therefore no current is flowing. Either of those are fine, and that's 15 marks sorted. The next focus specifically on forces, because that was a weak area in the walking talking mock exam. How does the speed of a car affect its stopping distance at maximum braking force? So if you have a higher speed, then it's going to take you longer to react, and it's also going to require the brakes to do more work to dissipate the kinetic energy, because the kinetic energy will be higher. So it will result in a longer stopping distance. 2, a teapot weighing 10 newtons is sat stationary on the table. What is the normal contact force? This is using Newton's third law. Every force has an equal but opposite force acting on a different object. So the teapot pushes the table down by 10 newtons, and therefore the table pushes the teapot up by 10 newtons. And because it's an upwards force, it's in the opposite direction, we have B minus 10 newtons. Question 3, typical running speed for a person. You're given 3 options there. We talked about this in class, this is just something you need to know. It's B, 3 metres per second. But probably the sensible thing to do is to think about, well, how long would it take for me to run 100 metres? It would take 100 seconds at 1 metre per second. Doesn't seem sensible. We're talking sort of 8 seconds-ish at 12 metres per second, which certainly doesn't seem sensible for any long distance. And I believe would net you a world record, or certainly close. But B is a bit more sensible, 30-odd seconds. We did talk in lessons about that being a bit slow for a sprint, but for a marathon that would be quite fast. So they're trying to average out all of those values. Question 4, gradient of a distance time graph. So you would have your distance, you would have your time, so your change in y over change in x would be distance, divided by time, which you know is speed, c. Question 5, which quantity is not a vector? That means which does not have both a size and a direction, speed only has a direction. So speed is a scalar, whereas force has a size, 10 newtons, and a direction, minus 10 newtons. And displacement is the vector form of distance. Question 6, brakes heat up when they're used because energy is transferred from and to, and if they're heating up, then it's always going to be transferring thermal energy, which gives me B straight away. Question 7. If something's moving, there must be an overall resultant force on it. This is Newton's second law. A resultant force causes an acceleration. So what that means really is that if there is a situation where an object is not accelerating, but is still moving, then this must be false. So if we imagine something going at a constant speed, the resultant force on that object is 0 newtons. Therefore, if something's moving, there must be an overall resultant force on it, is false. Because at a constant speed, there is no resultant force. That's Newton's first law. The acceleration of an object, question 8. You're just using your formula. A is delta V over delta T, change in velocity over change in time. Question 9, look at that graph and describe the acceleration between A and D. So acceleration is change in velocity. So we see here between A and B, my velocity is increasing, and it's increasing at an increasing rate. That is, I'm accelerating, and the acceleration is increasing for about the first half of my journey, and then it reaches a constant value. So the speed is increasing, and you're accelerating at a constant rate, and then reaching some constant value. B to C, speed still increasing, but at a slower rate. In other words, the acceleration is still occurring, but it is lower. So still accelerating, but a lower acceleration. C to D, you're staying at a constant velocity, and so the acceleration is 0, but you're still moving. It's just the acceleration that's 0, and it only asks between A and D. Some of you wrote about after D, wasn't worth any marks, but just for your peace of mind, constant gradient means constant acceleration, speed's decreasing, so that is a constant deceleration. And finally, question 10. In the experiment to measure reaction time, student A suspends a ruler from student B's thumb and forefinger. Student A drops the ruler without warning, and when student B catches it, the ruler has dropped 28 centimetres. Calculate student B's reaction time. And you're given that formula. So the first thing I'm going to look at is what information I have. So I'm told a number of things. I'm told student A drops the ruler without warning. When student B catches it, the ruler dropped 28 centimetres. So now my distance is 28. I know acceleration due to gravity is 9.8. I know my initial velocity, because they're dropping a ruler, you've done this experiment, is 0. So the only thing I don't know is v. So that gives me v is equal to the square root of 2 times 9.8 times 28. That's the square root of 548.8. So my velocity root answer is 23.4 meters per second. And then I want to find my reaction time. So now acceleration is change in velocity over change in time. That's one of your standard equations. My change in velocity is from 0 to 23.4 meters per second. I don't know how long that took. That's what I want to work out. But I do know my acceleration is 9.8 meters per second squared. So I multiply by delta t, divide by 9.8. Delta t is 23.4 divided by 9.8, which I can do on my calculator. Getting delta t is equal to 2.39 seconds. And that's another 15 marks sorted.